Question 10. Graph each of the following inequalities on the number line given. Note, x is an element of a different set, n, z, or in each case. Part A. X is less than 4, where x is an element of n. N is a natural number, it's a positive whole number. So x is less than 4, so it does not include 4. So we do not put a dot above the 4 because it's saying that it is less than 4. So we're going to put a dot above 3, 2, and 1 because it has to be an element of n. It has to be a natural number. And 0, minus 1, minus 2, minus 3, etc. they are not natural numbers. They are not positive numbers. So the only numbers that we put dots above are 1, 2, and 3. Part B. X is less than 4, where x is an element of z. Z is an integer, which is a positive or negative whole number. So again, we do not put a dot above the 4 because it says less than 4. So we put a dot above the 3, the 2, the 1, and we keep going down as far as we can, and the arrow indicates that this integer line goes on forever. So if x is less than 4 and it's an integer, it's all the numbers less than 4, all the whole numbers less than 4. So that's why we have dots. Now, if either of these questions had less than or equal to symbol, which looks like this, then we could have included the 4, because it would tell us that it was less than or equal to 4. But it does not have that, it only has the less than sign. Part C, x is less than 4, where x is an element of or being real number set. And this is any number on a number line. So fractions and decimals, whole numbers, positive numbers, negative numbers. So in this case, what we have to do is put an empty circle around the 4, because remember it's less than 4. So an empty circle indicates that we're not including the 4. But then we put a solid line all the way along the number line, and the arrow goes on forever. We put a solid line because it indicates all the little bits in between each of the whole numbers. So 3.5 would be about there. It indicates 3.5. 2.1 would be about there. A quarter would be about there. So we have to have a solid line whenever we have an or. Whenever we're indicating real numbers, we have a solid line. And a way to think about this is the letter or is at the start of the word road. So if we imagine that this is a road, it's a straight road. So whenever we have elements of or, real numbers, we have a straight line or we have a straight road. So this said x is less than 4, so we have an empty circle, less than 4. But if we had this symbol, which is less than or equal to 4, we would fill in the circle. We'd have a full circle. Question 11. Fill in the table by writing each expression in the form 2 to the power of p, where p is an element of n. So p is a natural number, a positive whole number. 1 has already been filled in for you. So we have 8, 32, 2 by 2 by 2 by 2 by 2 by 2. And then underneath that we have 2 to the power of 7 times 2 to the power of 10 and 2 to the power of 6 raised to the power of 4. So the first one, 8 is going to be 2 to the power of 3 because 2 by 2 by 2 is 8. 32 is going to be 2 to the power of 5 because 2 by 2 by 2 by 2 by 2 is 32. 2 by 2 by 2 by 2 by 2 by 2 is going to be 2 to the power of 6 because there are 6 of them multiplied together. 2 to the power of 7 multiplied by 2 to the power of 10 will be 2 to the power of 7 plus 10, which will be 2 to the power of 17. 7 plus 10 is 17. So when we're multiplying powers with the same base, we add the powers. So see the way we had a base of 2 and a base of 2? Well, since we're multiplying, we add the powers. If we were dividing powers with the same base, we would subtract the powers. And then 2 to the power of 6 raised to the power of 4 is going to be 2 to the power of 6 multiplied by 4, which is 2 to the power of 24. 6 by 4 is 24. Because when we're raising a power to a higher power, we multiply the powers. So 2 to the power of 6 raised to the power of 4. We have a power raised to a higher power, so we multiply them. Question 12. The letter J stands for Jake's age in years. Part A. Fill in the table by writing an algebraic term in terms of J to make each description. 2 have already been filled in for you. So the first one was already done for us, which is just J. So Jake's age now is just going to be J. Jake's age in 2 years' time will be J plus 2. So we're interested in creating these descriptions in terms of J, and that just means that J has to be in the answer. So Jake's age in 5 years' time will be J plus 5. If it was Jake's age in 6 years' time, it would be J plus 6. Jake's age in 7 years' time, J plus 7. Jake's age in 10 years' time, J plus 10, etc. Jake's age 4 years ago is going to be J minus 4. If it was 3 years ago, it would be J minus 3. If it was 2 years ago, it would be J minus 2. If it was 1 year ago, it would be J minus 1, etc. Twice Jake's age is going to be J multiplied by 2, which gives us 2J. Because in algebra, a number times a letter, we stick them together, but we normally put the number first. So twice Jake's age is J times 2, which is 2J. If it was 3 times Jake's age, it would be J times 3, which would be 3J. If it was 4 times Jake's age, it would be J times 4, which would be 4J, etc. 1/3 of Jake's age is going to be J divided by 3, which is J over 3, because that line there means divide. If it was 1/4 of Jake's age, it would be J divided by 4, which would be J over 4. If it was 1/5 of Jake's age, it would be J divided by 5, which would be J over 5, etc. Part B, solve this equation. Solve means to find the letter. 5m plus 2 is equal to 2m plus 35. We want to solve the equation, we want to get the m on its own. Now when we're doing solving, we usually have x's in our question, and it's usually get the x on its own. But in this case we have m's and we work it the exact same way. Now when we had x's on both sides, the rule was keep the x's on the side with the most x's. Since we have m's, we're going to keep the m's on the side with the most m's. So we have 5m on the left of the equal sign and 2m on the right of the equal sign. And 5 is clearly bigger than 2, so we're going to keep the 5 where it is, and we're going to get rid of the 2m. The opposite of plus 2m is minus 2m. So if I minus 2m, I'm going to cancel those out. But if I minus 2m to the right of the equal sign, I have to minus 2m to the left of the equal sign, because I always balance my equation. What I do to the right, I do to the left. What I do to the left, I do to the right. So I'm going to minus 2m to the left, and I'm going to keep the m's underneath each other. So 5m minus 2m is 3m. 5 minus 2 is 3. I bring down the plus 2. I bring down the equals. I've gotten rid of this, so I just have to bring down the 35. Now I have 3m plus 2 equals 35. Next thing, I'm going to get rid of the single number. So the single number being the plus 2. I also need to get rid of the 3 in order to get the m on its own, but the 3 is stuck onto the m, so I leave that till the end. So the opposite of plus 2 is going to be minus 2, so I minus 2 to the left of the equal sign, and I minus 2 to the right of the equal sign. I bring down the 3m, I've gotten rid of these, I bring down the equals, and 35 take away 2 is 33. Now I can get rid of the 3. The 3 is stuck onto the m, and two things stuck together in maths mean multiply, and the opposite of multiply is divide. So I divide by 3 to get rid of that 3, and if I divide by 3 on the left of the equal sign, I must divide by 3 on the right of the equal sign. And 33 divided by 3 is 11. And I can check on my right by subbing the 11 back into the original equation. So I'm going to swap the m for 11 on the left, and I'm going to swap that m for 11 on the right. So it's going to be 5 multiplied by 11 plus 2, which gives me 55 plus 2, and then 2 times 11 plus 35, which gives me 22 plus 35, and then 55 plus 2 is 57, and 22 plus 35 is 57, and since the equation balances, which means I have the same number on the left and the right, I know that my answer is right. M is indeed 11.